Welcome to this video. We were talking about basics of physics and today we discuss motions in a plane. What is motion? Movement of an object where its position in a straight line or in a plane or in space, the three-dimensional space, changes with respect to time. When its position changes with respect to time, we call a body to be in motion. It could be a particle body or it could be a body with a larger mass like Earth or anything else. What are scalars and vectors? When we have only magnitude to measure a movement, it is a scalar, while when we have magnitude as well as direction, it will become a vector. Vector can be resolved. When you apply two types of forces, the body may move in a resultant direction, that is R. Force OA and force OB could give a force OR as a resultant. So here MA is towards OP, NB is towards OQ, and the resultant R is the force in which the direction in which the body will move because of the result of these two forces. What is resolution of a vector? Splitting of a vector into two or more components is resolution of a vector. What is rectangular resolution? Resolution of vector into two mutually perpendicular vectors. Rectangular resolution is into two mutually perpendicular vectors. This is resolution into two mutually perpendicular vector. If you know R and if you know P, then we can resolve OQ as a component of this R, so that OP and OQ would have resulted in R. So R is resolved as I and J, or R is resolved as X and Y. What is X? X is the OP, how it is written caret I. What is Y? Y is OJ, how it is written caret J. So caret I, caret J, these are the two resultant components. These are the unit vectors along OX and OY. So vector OP or R is resolved as OP and OQ. What's a polygonal law? Polygonal law is a three-dimensional parallelepiped. Three-dimensional parallelepiped. This is how we resolve. So if we have a resultant force, suppose one force is acting A to B and another force is acting B to P, then on a OA, OB, OP, OE this line, we resolve OP as O to P. We resolve OP as something that is OA plus AB plus BP. We resolve OP as OA plus AB plus BP. This is a parallelepiped resolution, polygonal law. So in a rectangular resolution, what happens is R is resolved as X into I caret and Y into J caret. So V square equals to Vx square and Vy square. V square equals to Vx square and Vy square. What is Vy? V sin theta. What is Vx? V cos theta. This is the theta. V sin theta and V cos theta. This is how we resolve. While for polygonal law, the resolution is that resultant R is Xi plus Yj plus Zk. Xi plus Yj plus Zk in three directions. So the direction of OZ or K or Z is same as BP. So this is what BP is coming here. And already we have OA on one side. And then AB and OC are the same. AB and OC are the same. So we have R is Xi plus Yj and Zk. So R equals to square root of X square plus Y square plus Z square. This is vector resolution into rectangular or a polygonal thing. Now we have two types of velocities. One is uniform velocity, one is constant acceleration. What is uniform velocity? Uniform velocity is rate of change of speed is same. Rate of change of velocity being same is constant acceleration. So in V we have r dash minus r by t minus t. V equals to distance by time. Velocity equals to distance by time. R dash minus r is final and initial, and t minus t dash is the final initial time. So r dash equals to r plus original position plus v velocity into t dash minus t, the change in time, or r equals to r0 plus vt, initial position plus velocity into time. This is what it happens in a uniform velocity. In a constant acceleration, what happens? VAV is equals to r dash minus r by t dash minus t, or v dash minus v by t minus t. Acceleration is v dash minus v by t minus t. Change in velocity by change in time. But what is v dash equals to v plus acceleration into t dash minus t. So here it is initial position plus velocity into time. Here it is original velocity plus acceleration into change in time. This is how the constant acceleration formula works out. How do we calculate? Take this polygon where AB equals to OB plus OA. AB is OA plus AB is OB. OA plus AB is OB. So what happens? AB equals to OB minus OA, the resultant vectors. AB equals to OB minus OA, or R dash minus R dash minus R. What is R? R is xi caret and yj caret. R is xi caret and yj caret. What is R dash? X dash I caret and y dash j caret is R dash. So when we minus this, R dash minus R dash minus R is AB, that is x dash minus x into I caret plus y dash minus y into j caret. This is how we resolve for a motion in a plane. This is two dimension. This is two dimension. Suppose, how do we use this vector and scalar and its resolution for a motion in a plane or motion in a space? We can look at examples like if something takes off from land, if it has to go and land at another place, how the projectile will happen. For example, surface to air missiles, surface to surface missiles, or from the air you are dropping a bomb. Take these extreme examples of use of laws of physics and laws of motion for an object to be moving in a three-dimensional space. Now, in case of an aeroplane takes off from an airport, moves in a particular direction at a particular speed and lands in another airport, and an engine is running on the aeroplane to keep it moving in a particular direction. In case of a rocket, there is a rocket with fuel, and then all the fuel is burnt out, so there is a burnt out rocket weight, and then it goes into the space without the effect of gravity of Earth. When it comes back, after the thrust power is over, it comes into the Earth only with the gravity of the Earth. So that is how the rocket moves. Looking at a projectile, an object that is projected into space using some energy but thereafter moves under the effect of gravity alone plus resistance of air is a projectile. Something is thrown using a force. You throw a stone on a mango tree, or you throw a basketball up, or you hit a cricket ball. Anything is throwing it up by applying a force first. Thereafter there is no further force. That means within the ball there is no aeroplane engine. Within the stone that you throw on a mango tree, there is no aeroplane engine to give it a force. It moves with no further energy. Only initially there is some energy to throw. An energy that makes it move against the gravity. First it is given. Thereafter it moves only what is there? The gravitational force, which is always there, and some small pressure or friction because of the atmosphere or the resistance. Now this resistance of air or atmospheric pressure is normally considered as zero. Right? So what is a motion along a horizontal path? The motion along a horizontal path will be uniform velocity. Rate of change of speed will be uniform on a horizontal path. The motion along vertical path, how it will come back to Earth? This will be uniform acceleration. What is that? That is gravity. So because of this uniform velocity on the horizontal path and uniform acceleration on the vertical path, it will have a parabolic path. A projectile will have a parabolic path. Whether you fire from here or you throw it from an aeroplane here, it will have a parabolic path. So what are the formulas that apply for this, or how it is calculated? When a projectile is fired from a height of h above, with a velocity of u parallel to the horizontal, when it is fired like this from an aeroplane, a torpedo or a missile, its time of flight t equals to 2h by g. 2h by g. This is the height above the ground. Suppose 1000 meters, 1500 meters, 2000 meters above the ground. This is this height into 2 divided by g is a gravitational force. Square root of that is the time it takes for the flight. What is the flight? The time the projectile, the missile, the bomb takes before it lands at point Q on Earth. So this time is this height into 2 divided by gravitational force, square root of that is the time. Time is t equals to root 2h by g. Horizontal range, how far it will go if the plane is at this point in time when the torpedo or the ship is firing a torpedo or a plane is firing a missile at this point, how long it will go, what is the range it will go? Range is u into root of 2h by g. U into 2h by g is the time, u is the initial velocity into time, initial position into time, u into 2h by g. u into 2h by g, where u is the initial velocity. This is the initial velocity with which the plane was moving when it is throwing the or arming the missile. What is the velocity at any given instant here or here or here at any point in time? What is the velocity? Equals to u square plus g square t square. G square is a gravitational force. T square is the time. U is the initial velocity. This is the velocity at any instant. And the angle beta which the velocity vector makes with the horizontal, the angle which the velocity vector makes with the horizontal, this is the horizontal. The angle at which it falls is the angle beta, and this is tan beta equals to gt by u, gravity time by initial velocity, tan beta equals to gt by u. So when we know tan beta which is gt by u, we will know at what angle the parabola or the projectile will come down. How far it will go and fall far away? U equals r equals to u into 2h by g. So these are the formulas that is used. For example, if you are sitting in a plane and firing a missile, to know where it will go and hit. X equals to ux into t plus half into x t square. Initial velocity into time plus half into acceleration into t square, where acceleration we take as gravity. That is why t equals to x by u initial, and this is initial velocity. Y equals to, instead of ux you will have uy, this is y. In ux you will have uy into t plus half into ay into t square, ay into t square. Initial velocity we take it as 0, then what will have, only second portion will remain. Initial acceleration or gravity, if you take it as 0, only one portion will remain. So here initially there is no acceleration, x equals to ut or t equals to u by x, this will become 0, ax will become 0. Here what we do, we take uy as a 0. Uy is 0 because what? Vertically when it is falling down there is 0 acceleration, 0 velocity, 0 vertical velocity, and then acceleration is gravity, it is always there. So half into a by t square. So y will become g by 2u square into x square. So when you take a y square root of this, so that is how we calculate the time or the distance in case of a parabolic projectile motion. Now another thing is, whatever is thrown from a plane, thrown from ground to surface, will come back to surface in the parabolic fashion. Whatever is thrown from a plane also will fall down in a parabolic motion. When you are flying on a parachute and escaping from the plane, you will fall down in a parabolic motion. When a plane catches fire in an accident and falls down, it will follow a parabolic motion. So when an object is thrown into space that moves under the effect of gravity alone, then it is called a projectile. This projectile can be fired parallel to horizontal or can be fired at an angle to horizontal. It can be fired at an angle to horizontal. It is thrown up. It can be fired up. So when it is fired up, the motion along horizontal path is negligible because of air friction, and the initial velocity remains the same. Initial velocity remains same. Here it is uniform velocity. The initial velocity remains the same. That is u cos theta. Initial velocity will remain same, u cos theta. Motion along vertical path is decreasing velocity. Motion along decreasing is uniform acceleration because of gravity. That is decreasing velocity. That is gravity. Initial velocity being u sin theta. Initial velocity on horizontal path is u cos theta. Initial velocity along vertical path is u sin theta. Acceleration is minus g. G is a gravity. So trajectory, the path in which the object will move is called the trajectory. The trajectory will be y equals to x tan theta minus g by 2 u square cos square theta into x square. Trajectory is, when you fire a bomb from a tank, you can look at the trajectory. A small bullet, when you fire for a short distance, it will go straight. From a pistol, when you are trying to fire upon something that is 2, 3, 4, 5, 10 feet away from you. But when you are firing something which is far away, 100 feet, 1000 feet, then it will form a trajectory which will be parabolic motion. So the time of the flight is 2u sin theta by g. Here the time is 2h by g. It is here 2u sin theta by g. U sin theta. U sin theta is the velocity, vertical velocity. U cos theta is a horizontal velocity. Maximum height reached is h equals to u square sin square theta by 2g. Maximum height is u square sin square theta by 2g. Here the horizontal range was u into root of 2h by g. Here it is u square sin square theta by 2g, the maximum range. Horizontal range is r equals to u square sin square 2 theta by g. This is the horizontal range. Maximum height is h. Now here ux equals to u cos theta, ux equals to u cos theta, and uy equals to u sin theta, uy equals to u sin theta. Y is the height and x is the distance. So x equals to ux plus half t square, x equals to, here also you have uxt plus half into axt square. This will become ux plus half t square, and y will be uyt plus half into ayt square, uyt plus half into ayt square. Why? Because along horizontal path initial velocity is same, along vertical path you have a decreasing velocity, that is gravity. Why it is decreasing velocity? It cannot go up. Whatever it has gone up with a thrust will come down because the acceleration will reduce. It will not go up. The acceleration to go up will become negative as it is falling down. Here there was no initial acceleration. It will be uniform acceleration downwards towards the gravity only. So this is how the formula is. So at 45 degrees centigrade if you throw something, at 45 degrees centigrade if you aim and fire something, h is maximum and u square by 2, maximum height is u square by 2, and the range is also maximum. Vertical height is u square by 4g, horizontal range is u square by 2, horizontal range is u square by 2, and vertical height is maximum, which is u square by 4g, u square by 4g, that is when you fire at 45 degrees, when theta is 45. So these are some basics about the projectile motion. Thanks for watching Laws of Motion.